5.1, we're only going to do the evaluation of polynomials. So let's go to 5.1. Okay, you guys are familiar with a couple of polynomial functions, right? You are very familiar with y equals mx plus b, right?
I know what it is. I don't know how to do it.
It's a... you're a funny guy. So that's mx plus b. That's x to the first, right? What else? What else are we really familiar with?
Adding, subtracting.
That's right. The quadratic function, right? The quadratic polynomial function. Now, just because there's no exponents here, or it's because it's a 1, right? And then the c actually has it is being multiplied by a variable. It's just that variable is x to the 0. Okay? Anything raised to the 0 is 1. 1 times any constant is that constant. That's why we don't put x to the 0 there, right? If you notice, the exponents are from highest to lowest. That's what we call standard form. So this is standard form of a polynomial function. Technically. We just call it standard form. Okay. Not every function is a polynomial function. And there's a difference between, because it's like a, I wish they would have taught you guys Venn diagrams. Anyway, just remember that every function is not necessarily a polynomial function, okay? So let's discuss the different types of polynomial functions. If I have a degree of 0, I end up with just a constant, right? Well, we could just use c for constant. If you really want an example, you could put a number there. I don't know, number 4 is fine. That's a numerical example. Now, linear polynomial function is when I have degree 1. That's where that slope intercept comes in, right? What kind of shape is this? A linear function? It's a line, right? Yeah, linear line. Okay, so I'm going to start putting these in standard form where we have the coefficients a, b, c, d, whatever, okay? So I'm going to say that this is ax to the first plus b. Okay. There's my example of a linear polynomial function. Quadratic, well, here's our quadratic right up there. It's degree 2 because that's the highest degree on my exponents, right? So I have ax squared plus bx plus c. Then we have cubic polynomial functions. So that would be ax cubed plus bx squared plus cx plus d, where d is our constant, right? And then it just keeps going on from here. Let's see, quartic is degree 4. So I have ax to the 4th plus bx cubed plus cx squared plus dx plus e. Then I have a quintet. Holy moly. Ax to the 5th plus bx to the 4th plus cx to the 3rd plus dx squared plus e, right? Jeez. Ex to the 1st plus an f. And then when we get to degree 6, we just say We just say, hey, it's degree 6, degree 7, degree 8. We don't have a special name for it. Okay? But we still like to write them out. Ax to the 6th plus bx to the 5th plus cx to the 4th plus dx to the 3rd plus ex squared plus fx plus g. Isn't that special?
Does it go into infinity or degree?
Yes.
What's the highest?
Yes, it goes to infinity.
Right.
Because it's English class.
And boy, is that math fun when you start
What
looking
numbers-
at
what
infinity
numbers
for your
after?
exponents.
What
Huh?
number's before infinity?
What's before infinity?
Yeah, what number?
Infinity minus 1. And I'm not being funny, that's how we write it.
Really?
Yeah.
Infinity minus
That's the number before infinity. When you get into theoretical mathematics, that's how you write it. That's the number before infinity. All right. Decide whether the function is a polynomial function. I told you before, not every function is a polynomial function. We used to go into those types of functions that are not polynomial functions, but I think we are skipping it this year for some reason, or last year for obvious reasons. So, to write in standard form, degree, type, and lead coefficient, the first thing you have to do is put it in standard form. Okay? Highest degree first. So my highest degree is this negative 3x to the 4th, right? And then my next highest is going to be 1/2 x squared, so it's a positive 1/2 x squared. And then I have a constant over here, minus 7. My highest degree for what type is it? Well, I look at degree 4, and it's a quartic. Quartic. And my lead coefficient is A. Okay? My lead coefficient is A, the coefficient A. So my coefficient A here is -3. It's probably one of the easiest things that you guys done this semester, huh? Or this year. All right, number 2. We're going to write it in standard form. So my highest degree is the 2x to the 5th. Next one is plus 6x squared, and then I have an x to the 1st here, so plus x. My degree is what? 5.
Which is a quantic.
Yep, quintic. And my lead coefficient? 2. Easy enough, right? We did this, right? When we were doing composite of functions and function notation and, the operations of functions. We just substituted in values for our x, okay? So here's our function. F of x equals 2x to the 4th minus 8x squared plus 5x minus 7. They want us to substitute in 3 for x. Question? Yes. Okay, so everywhere where I see an x, I'm going to substitute in the value 3. So I have 2x, I'm going to put parentheses, to the 4th minus 8 parentheses for the x squared plus 5 parentheses minus 7. Then I'm going to substitute in 3 for my x, right? So here's a 3, here's a 3, and here's a 3. Now that I took all that time to put parentheses in there and write it out, I can easily do this on my handy dandy calculator, right? So I have 2, and put it in exactly with the parentheses, okay? Otherwise, it does funny things. So, 2, parenthesis, 3, parenthesis, raised to the 4th, minus 8, parenthesis, 3, parenthesis, raised, squared, or you could use a squared button, plus 5, parenthesis, 3, parenthesis, minus 7, and hit enter. 98, that's what I got. All right, let's do it again. This time, I say my x equal 1. So wherever I see an x, I'm going to, even in the function notation, I'm going to put in 1. Okay? So I have the f of 1. Pardon me? Oh, was it cut off on the screen? Sorry. It doesn't cut off on my laptop. So, all right. So I have 3 absolute bar value bar. My x, still going to use parentheses. I know it's a kind of an easier equations, but I'm going to do it nonetheless. Minus 2 absolute value bar, and really kind of shade these bars because even myself, I have mistaken these bars for a 1. Alright, so I'm going to substitute in 1 for my x. And since this is pretty simple, I'm going to do this in my head and not use my handy dandy calculator.
Did we type it in the calculator?
Oh, if you wanted to. Let's see if I remember how to do this myself. Let's see, 3 times, I think you have to go to your math button, num, and absolute value. Now, I think yours actually puts in bars, because you guys have the newest and latest update. I'm going to put in 1, close the parentheses. Now, you guys will probably have to arrow out of your absolute value bars. Oh no, I forgot the minus 2. Minus 2. Are we good? Hit enter. I got 3. So 1 minus 2, that is not correct. Oh, maybe it is. 3. I forgot about multiplying it by the 3. 1 minus 2 is negative 1. Absolute value of negative 1 is 1 times 3 is 3. Look at that.
Would the 1 be negative 3 or no? Or am I getting them mixed up?
I'm not sure what you're asking me. So let's do this in steps.
Okay, I'm sorry.
3 absolute value. 1 minus 2 is negative 1, right?
Yeah.
So this is 3. I'm going to drop the absolute value bars. So I'm going to make that a positive 1
Okay, now I get it.
equals 3.
Alright.
Okay.
I was a little confused.
Yeah, absolute value bars, they even confuse me.
Sorry for taking so much time.
No, we got plenty of time. This is my last problem for the day. We're gonna leave. This is graphing. I'm gonna leave that for tomorrow. All right, the f of g. Let's see. X is negative 2, so I'm going to substitute it in for my x, even in my function notation, because that's just the kind of guy I am. So I have the g of negative 2 equals 4 parentheses squared plus 2 parentheses for my x minus 1. Then I'm going to substitute in that negative 2 for x. Now, do you want to use the handy dandy calculator? So I've got 4 parentheses negative 2 squared plus 2 parentheses negative 2 minus 1, and I get 11. And actually, this isn't that hard to do in your head. Negative 2 squared is 4. 4 times 4 is 16. Positive 2 times negative 2 is negative 4. And then minus 1. 16 minus 5 is 11. And since I'm such a nice guy, I'm going to stop here because this starts graphing. This starts the graphing. And I'll leave graphing till tomorrow because you guys are probably tired of hearing me being a Monday and all.
What part of the homework?
So, on the homework, good question.
So there's one that says coming rain.
Yeah, good question.
That's,
So, on your homework, for part 1 of 5.1, you could do numbers 1,
1, 2,
2,
11, 12.
yep, and 11, 12. Now, if you walk out of here with homework to do, you certainly have wasted class time. Because 4 problems should not take you a half an hour. 1, 2, 11, and 12.
Half is more than that.
Is this 4th? No, this is 3rd hour.
Yeah, whatever, dude.
Whatever,
Whatever.
dude. I like that. Whatever, dude. I got to stop my recording before I use profanity.